In the previous 4 parts, we explored numerous concepts about R vectors. In this final part, we will put all of that knowledge to test by structurally solving 11 questions involving vectors. It is very much possible that you might be asked one of these questions in a written test or in a technical interview round. Let's read the first question. Write a R program to build a vector with integers from -10 to +10 and with a difference of 3 between any two consecutive integers. Store this vector into a variable named x. There are two tasks in this question. Number 1 is to create a vector and number 2 is to store the vector to a variable named x. We learned in part 1 that the combine and sequence functions are two of the available options that can be used to build vectors. We will use the sequence function here since we require a difference of 3 between any two consecutive integers. To create this vector, we will type seq, which stands for the sequence function, followed by from is equal to -10, 2 is equal to 10, by is equal to 3, where from is equal to -10 indicates the starting number of the sequence, 2 is equal to 10 indicates the last number of the sequence, and by is equal to 3 indicates the difference that needs to be maintained between any two numbers. Now when I press enter, the contents within the vector are printed in the console. Now the final task is to store the vector to a variable named x. So to do that, I'll press the up arrow key on my keyboard to get the previous operation and add x and an assignment operator at the start. And when I press enter, the vector will be stored within the variable x. To view the contents of x, simply type x and press enter. Let's summarize what we learned. We learned to create vectors and essentially to create vectors with a desired common difference. We learned to store the vector to a variable and finally learned to print the contents of the vector in our console. Let's move to question number 2. Write a R program to build a vector with letters A, B and C and store this vector within a variable named y. Next, append vector y to vector x after the fifth element of vector x and store the results into a new variable named z. There are 4 tasks in this question. Number 1 is to create a vector. Number 2 is to save the results to a variable named y. Number 3 is to append vector y to vector x. And number 4 is to store the vector to a new variable named z. We will use the combine function this time since the vector is pretty straightforward. Type y followed by the assignment operator, and within the combine function type the letters A, B and C separated by comma and enclosed between double quotes and press enter. Type y and press enter to view the contents of this vector. We will use the append function for tasks 3 and 4. So type z followed by the assignment operator, and within the append function pass the vector x to the first parameter x. Now we want to append vector y to vector x, and hence we pass y to the values parameter by setting values is equal to y, and finally set after is equal to 5 because we want to add the elements of y after the fifth element of x. Type z and press enter to view the output. Let's summarize what we learned from this question. I will not repeat any learning from the previous question. We learned to create a vector with strings or non-numeric values, and we learned to use the append function. Let's move to question number 3. Write a R program to sort the newly created vector z in descending order. We will use the sort function here that we explored in part 2 of this series. Type sort and pass the vector z to the first parameter x. Next set the decreasing parameter to true and press enter. Setting decreasing parameter to true sorts the vector in descending order, and setting it to false sorts the vector in ascending order. To summarize, we learned to use the sort function and also learned about one of its crucial parameters called decreasing that helps us tell the sort function whether to sort in ascending or descending order. Let's move to question number 4. Write a R program to count the number of times an element is repeated in a vector. This question essentially asks us to count the number of occurrences of an element within a vector. So let's divide it into simple tasks. Task 1 will be to identify the element from the vector, and task 2 will be to count all of its instances. Let's say I have this vector u which has certain English alphabets, and say I want to count the number of times the letter G is repeated. The first step is to identify the alphabet G from vector u. We learned in part 4 that typing v is equal to g will give us a true in place of all instances of g and false in all other places. Now since true and false correspond to 1 and 0 in R, we can add the elements of this vector to get the count of repetitions. In part 3, we learned that we can sum the elements within a vector using the sum function. Hence, we will nest the previous operation within the sum function and get the count of all repetitions of alphabet G. Let's summarize what we learned from this question. We learned to use the double equals to operator to identify the desired element inside a vector. We understood that true and false correspond to 1 and 0, and hence we can apply our learnings in vector arithmetic to vectors with logical or true-false values. Finally, we learned to sum the values within a vector using the sum function. Let's move to question number 5. Write a R program to extract all numbers that are greater than a user-defined value. We already know how to apply rules to a vector and extract elements from it. But this question poses a new challenge, and that is to use a user-defined value. So our first task will be to create a variable that can store this user-defined value, and next task will be to use it within our rule. We will use the vector x that we built in question number 1. I'll create a variable n and assign a value 7, assuming I want to extract all numbers greater than 7. Next, write the rule x greater than n within the square brackets following x. And as you can see, all number greater than 7 are printed in the console. I could assign a different value, say for example 2, and run the same rule again to get a new set of qualifying numbers. Let's summarize what we learned from this question. We learned to subset a vector using a variable as an input. Let's move to question number 6. Write a R program to extract all even numbers from vector x. Even numbers are numbers that are divisible by 2, or in other words, leave a 0 remainder when divided by 2. In the second video in this channel, we learned different mathematical operators, and one of them was the operator to find the remainder, which basically contains two percentage signs put side by side. We can pass this rule within square brackets to get all even numbers from vector x. In the first part of this rule, that is x followed by the remainder operator followed by 2, we compute the remainder when each element of x is divided by 2. Next, using the is equal to 0, we identify all instances where the remainder is 0. And by enclosing the rule within square brackets following x, we tell R to extract all such numbers from x that leave a 0 remainder when divided by 2. Let's summarize what we learned from this question. We learned the definition of even numbers and the operator that is used to compute the remainder in R. Let's move to question number 7. Write a R program to find all integers between 10 and 50 that are divisible by 3 but not by 2. We will first create a vector with elements from 10 to 50 and store it within a variable named u. Based on our learnings from the previous question, we now know how to individually check for divisibility with 3 and 2. We learned in part 4 that we can combine rules using the and or operators. Here, we will use the and operator since we want both the conditions to be fulfilled. The and operator can be passed using the ampersand sign. Let's summarize what we learned from this question. In this question, we learned to combine multiple rules using the AND operator and also looked at the rule which used the not equal to sign. Let's move to question number 8. Write a R program to extract the last value from a given vector. We have learned in part 1 that we can find the length of a vector, which is also the count of the elements within a vector, using the length function. We also know that we can enter a number within the square brackets to extract an element. Say for example, I have a vector with 10 numbers, then I can extract the third element by entering 3 within the square brackets. Similarly, I can find the last element by simply typing its position, that is 10. But in the real world, I might not have the comfort of manually visualizing the vector. Hence, I need an approach that can automatically identify the position of the last element. One approach to achieving this is using the length function. The length function outputs the total number of elements within a vector. For example, when I pass the vector with 10 numbers to the length function, it outputs the number 10, which also happens to be the position of the last element. We can use the same logic to find the last element by passing the length function as a rule within the square brackets. Let's summarize what we learned from this question. In this question, we learned about the length function which counts the number of elements within a vector, and also learned about using the length function to extract elements from a vector. Let's move to question number 9. Write a R program to replace the last two elements of vector x with alphabets A and B. We learned in part 4 that we can modify the elements by writing the original vector to the left and the new vector to the right of the assignment operator. Say for example, I have typed the code to replace the second element of my sample vector A with 5. We can use the same approach to solve this question as well. Using our learnings from the previous question, we now know the approach to identify the last two elements from the vector. Here, I identify the last element of vector x using the length function and second last element by subtracting 1 from the output of the length function. Next, I enter the assignment operator followed by a vector with alphabets A and B. As you can see, when I type x and press enter, the output contains alphabets A and B in the last two positions. Let's summarize what we learned from this question. In this question, we learned to identify the last two elements from a vector and also to replace them with new elements. Let's move to question number 10. Write a R program to list and count the unique values from a given vector. There are two tasks in this question. Number 1 is to find the unique elements from the vector, and number 2 is to count them. I will use the vector u that we previously used in question 4 to illustrate the working. We already know that we can use the length function to count the total elements within the vector. Now I am introducing a new function here called unique, which is used to list the unique elements from a vector. Type the variable containing the vector or the vector itself within the unique function, and the function will return all the unique elements. Next, we can nest this operation within the length function to count all the unique elements. So let's summarize what we learned from this question. In this question, we learned to apply the unique function and to also count the unique elements within the vector. With these learnings in place, let's move to the last question. Write a R program to find the nth largest value in a vector. This is a tricky question, so let's take a step back and see how we can think about this problem. You can see 5 random numbers in the first row of the spreadsheet and say I want to identify the third largest number. Now the third largest number here is 5 and it is in the last position. Here we could apply our knowledge from one of the previous questions and extract the last element from the vector using the length function. Let's say I shuffle the numbers and list them in row number 3. Now 5 is present in the second position. You could say that we could use the approach of entering the position within the square brackets and extract it. But imagine if I expand this list to thousands of numbers, then the approaches we looked at might not be the most optimum solve. So how could we standardize the approach? Think about this. Is there a way I could position the elements within the vector such that 5 is always in a certain fixed position? Any thoughts? Pause this video and share your approach in the comment section. Let's say what happens when we sort this vector in ascending order. As you can see, 5 lands in the third position. If I rearrange the terms in the vector and sort it again, then as you can see that 5 again lands in the third position. I can repeat these steps for any arrangement of numbers and 5 will always land in the third position. At this point I can safely enter 3 within square brackets and extract the third largest number. I can change 3 to 4 to get the fourth largest number and so on. Now if the use of square brackets along with the sort function seems strange, then remember that the output of the sort function is a vector, and by attaching the square brackets, we can apply all the rules about vectors to the output of the sort function. In fact, every function that we have learned so far returns a vector as an output when its input is a vector. That's it for this video. Don't forget to subscribe and share this with your friends and colleagues who are interested in learning R. Good luck and happy learning.